Multiknit Proprietary Limited strives to employ highly motivated and skilled people. It has a workforce of hundreds of people and boasts a senior management team with an average service record in excess of 18 years. Multiknit has two highly sophisticated multi-million rand manufacturing plants located in Makushlu and White River, Mpumalanga, South Africa. The plants are proudly run by the most experienced technicians in the knitted synthetic shade netting and produce industries. These plants meticulously apply an exacting step-by-step quality control program designed to ensure that its customers can rely on every multi-knit product they buy to exceed the industry standard. The Multiknit group of companies comprises of three divisions: Knitix, SACPro, and Multiknit International, all of which are highly focused in the markets they serve. At Multiknit we manufacture with virgin HDPE, meaning our raw material has never been recycled, which adds to our quality and product longevity. Keeping in mind the measures we take to ensure our raw materials are of the highest grade, coupled with the obtained SATA certification, an independent auditing and certification body, we stand firmly behind our products and are proud to be amongst the industry's leaders in knitted fabrics. Every Knitix product has been made to an extremely high standard, using the best pigments, high-density polyethylene and ultraviolet inhibitors available. Rigorous burst, tear, shade, and other tests are carried out to meet stringent standards set out and regulated by various global standards providers such as the South African Technical Auditing Service, the Standards Australia, the Californian State Fire Marshal, and the American Society of Testing and Materials. Our lock-stitch pattern, obtainable through a knitted construction, means the fabric will not fray or unravel when cut. The mesh size governing the shade percentage is fixed or locked in place, making it impossible for it to be altered. Due to the knitted lock-stitch pattern, our shade netting allows for easy joining and repairing should the fabric be accidentally torn. Our fabrics are also stented, which assists in eliminating sagging and looseness in the fabric after installation. In essence, what this means is we expose the fabric through a unique process which firms and tightens the fabric, giving it a composite memory that when stretched will revert back to its original state under the heat of the sun. The raw virgin HDPE material we use comes with certified lab results from the supplier. When we receive a shipment, we take random samples from the various pallets. These samples are then checked for two criteria. For example, melt flow rate. This value is a measure of viscosity at 190 degrees Celsius for most polymers, and 260 degrees Celsius for polypropylene. The measurement is made on the melt flow indexer. The polymer is fed into a small heated tube that is then placed under weight. The weight will vary depending on the material being tested. In our case, the weight is 5 kilograms. The portion that flows through a small orifice at the bottom of the tube is then cut and measured. The result is quantified in grams per 10 minutes. A higher value indicates higher viscosity. Each manufacturing plant has its own requirements depending on what they manufacture. Multiknit utilizes gravimetric blenders, which are automated raw material feeding systems. These systems accurately weigh 2 or more components and then mix them together before they are processed in either a mono extrusion or a film blower machine. In the mono extrusion process, smaller extruders and longer lines are used. The products developed from this process have a very small diameter and many ends. Smaller diameter allows very swift cooling. On the cooling of filaments, they are drawn and wound onto the packages. The drawing process is done using comparatively large ovens having godette rolls on its every side. These rolls are used for drawing the filaments to the accurate denier. After this process, the product is wound onto bobbins. The monofilament may either be used straight off the bobbins, or the bobbins will be wound onto bigger beams with multiple individual yarns, called ends. This is determined by the specific product requirement. With blown film extrusion, the material from the gravimetric blender is dropped into a barrel with a screw. Here the material is heated, melted, and mixed while being forced down into the die opening. Air is introduced via a hole in the center of the die to blow up the tube like a balloon. The tube of film then continues upwards, continually cooling, until it passes through nip rolls where the tube is flattened and cut into 2 sheets. These sheets are then rolled onto beams for use on the knitting machines. The film beams are placed onto an in-house designed feeding system that slits, heats, and stretches the film into its final state known as tape yarn. From this feeding system it goes into the knitting machines to be knitted into various patterns and products. When performing tensile tests, depending on the product, fabric samples of either 50 mm or 100 mm width are placed in the tensile tester. Fabrics are tested in both warp and weft directions. The instrument determines both the maximum tensile strength and the maximum elongation at break, which is a percentage of its original dimensions, before it breaks. A burst test that determines the resistance of the fabric is conducted by placing a fabric sample on top of a latex bladder. A heavy metal clamplate is locked into place on top of this and air pressure is then forced through a 200 mm opening. The kilopascal pressure measurement is recorded at the point of failure. Our testing laboratory also performs other tests, for example, material weight, which determines the grams per square meter, as well as flame retardant tests using a methane burner. Other strength and durability tests were also conducted on our fabric. For the load test, an industrial I-beam frame was constructed to conduct this field test. Extreme 32 fabric was secured by Keda railings on all sides. 25 kg bags of HDPE were then loaded onto the fabric. At 4,000 kg, the top flange of the I-beam started bowing inwards due to the load. An additional anchor was then secured to the top flange to prevent further bowing. We continued to load the net up to 5,000 kg with no failure occurring. We left the load for a week before we removed it, and after a few days the fabric returned to its original shape and tightness. Our hail simulation test consisted of more than 20 tests. Ice balls of approximately 40 mm in diameter, replicating large hailstones, were constantly fired at the same spot on the fabric to test its strength and resilience. We started the test by firing the ice balls at the fabric at 56 meters per second, or 210 kilometers per hour, and went up to 76 meters per second, or 275 kilometers per hour. The maximum velocity achieved was unfortunately not accurately recorded by the Caldwell Ballistic Precision Chronograph. The fabric returned to its original shape and tightness soon after the tests were completed. Knitix is known as a world leader in the manufacture and supply of knitted synthetic fabrics and shade nets which are used in the agricultural, domestic, industrial, civil, and mining industries. Our product range consists of the following: Spectranet, Color Shade Extreme 32, Color Shade Dry Z, Color Shade Z25, Nipole, Ground Sheets, Perimeter Nets, Windbreak Nets, Ropes and Twines, Frost Guard, and Aquaculture Netting. The color shade range of fabrics are the most durable and colorful decorative shade netting available that enhances and protects your valuable assets. These contemporary all-climate protections are the best solution for industrial, commercial, and domestic applications and comes in an exciting range of trendy fade-resistant colors. Color shade fabrics are used for tension structures, shade sails, and many other interesting and creative shade structures, and combines the benefits of privacy, sun, wind, hail protection, and enhances the appearance of outdoor surroundings. After 10 years of extensive research and testing, Dries was developed because of our ongoing commitment to our research and development policy. Dries, the revolutionary all-weather shade net, provides the ultimate in all-weather protection against the harsh elements of sun, rain, hail, snow, and wind. Dries is available in a variety of attractive colors, and this stylish and practical fabric will enhance the appearance of your outdoor surroundings, whilst transforming and protecting your valuable assets. Spectranet is the ultimate shade net for climate control and light wave manipulation in the agricultural and horticultural industries. Spectranet is well known for providing plant and crop protection against harsh weather conditions and damage caused by hail, wind, insects, birds, drought, and sunburn. The brand name Spectranet aptly describes the product's ability to manipulate and alter the quantity, quality, and relationship of blue, green, red, and far-red wavelength energies absorbed by plants. In conclusion, we are proud to say that we have been world leaders in the manufacture and supply of knitted synthetic fabrics since 1964. The Multiknit brand has worked hard to obtain and maintain its reputation for service excellence and products that are of high quality and reliability.